This video will talk about circular economy. We will understand what is circular economy, what are its benefits, what are circular economy business models, what do they look like, and we will look at a few examples of real-life circular economy being applied in the real world. So what is circular economy? It is a system where materials never become waste and nature is regenerated. Products and materials are kept in circulation through processes like maintenance, reuse, refurbishment, remanufacturing, recycling, and composting. The circular economy tackles climate change and other global challenges like biodiversity loss, waste, and pollution by decoupling economic activity from the consumption of finite resources. This model is what we are used to from the beginning of the Industrial Revolution, the linear economy, where we extract resources, produce products, distribute these products are then consumed by users, and then they go to waste. The circular economy adds an extra step after the consumption stage, where products are reused, repaired, or recycled, and then they go back into the production, closing the loop on the waste stage and reintroducing materials into the production stage once more. Here we have three different models of economy. The first one is the linear that we are used to, where we take, make, use, and then put to waste. The recycling economy, which is a bit better, introduces recycling after reuse so that some of the materials or products can be remade again and reused. However, there is still waste in this process. The circular economy model makes sure that there is minimal take, and then products are made and used, and then there are several aspects that are added. Products can be returned and remade again, they can be reused, they can be repaired, and they can be recycled, closing the loop on the materials and products used and minimizing waste. So the benefits of this is that circular economy transforms our current throwaway economy, eliminating waste and pollution and circulating resources. It tackles climate change and biodiversity loss simultaneously. It separates the ability to achieve economic growth from the consumption of natural resources. It creates jobs, prosperity, and resilience while cutting greenhouse gas emissions, waste, and pollution. It also presents a business case for each sector to be more sustainable while increasing competitiveness through this innovation of the normal economy process. Here we look at a concept called the 10 R's. If we look at this diagram, the bottom R's are the normal linear economy actions that we can take. And by going up this list, it increases in circularity, where the top strategies are the ones that are the most circular. If we talk about having smarter product use and manufacturing, the first step would be to refuse, which is the most circular action you can take, is to make a product redundant by abandoning its function or by offering the same function with a radically different product. We can also have a rethink strategy where we make product use more intensive, for example, by sharing this product. We can also reduce by increasing the efficiency in product manufacturing or use by consuming fewer natural resources and materials. And then if we want to extend the lifespan of a product and its parts, we can reuse. The products or parts can be reused by another consumer of discarded product which is still in good condition and fulfills its original function. If we can't reuse, we can repair. By repairing and maintaining defective product, it can be used with its original function. If we can't do that, we can refurbish by restoring an old product and bringing it up to date. We can also remanufacture by using parts of discarded product in a new product with the same function. If we can't do that, we can repurpose the product by using the product or its parts in a new product with a different function. And if we cannot do any of that, we can go to useful applications of materials like recycling, where we process materials to obtain the same high-grade quality or lower-grade quality. And if we cannot recycle, then the last option we have is to recover by incinerating material with energy recovery. So still, we can extract energy out of the waste and dispose of it in a responsible manner. So what are the principles of circular economy? The first principle is eliminating waste and pollution. Currently, our linear economy works in a take-make-waste system. We take raw materials from the earth, as mentioned before, we make products from them, and we eventually throw them away as waste. Much of this waste ends up in landfills or incinerators and is lost. Some of it even ends up in water systems like rivers and oceans. This system cannot work in the long term because the resources on our planet are finite. They're not infinite. The second principle is to circulate products and materials. This means keeping materials in use, either as a product or when it can no longer be used as components or as raw materials. This way, nothing becomes waste, and the intrinsic value of products and materials are retained. This is an important diagram for circular economy. It's called the butterfly diagram. It illustrates the continuous flow of materials in a circular economy. It's divided into two main cycles, the technical cycle in blue and the biological cycle in green. In the technical cycle, products and materials are kept in circulation through processes of the 10 R's, such as reuse, repair, remanufacture, and recycle. For the biological cycle, the nutrients from biodegradable materials are returned to Earth to regenerate nature. We can do this by the extraction of biochemical feedstock to produce low-volume, high-quality chemicals through anaerobic digestion and biogas generation, where we use waste materials, we break them down and produce energy instead of letting them go to waste. And this energy is reused into the manufacturing process once again. This way, we minimize systematic leakage and negative externalities from the resources and materials we use. The final principle of circular economy is to regenerate nature. By moving from a take-make-waste linear economy to a circular economy, we support natural processes and leave more room for nature to thrive. If we look at the materiality of our linear economy in the past 100 years, we can find that there are several risks linked to this model. The environmental risks, for example, first example is that there's a transgression of planetary boundaries. We as humans are crossing the planet's limits in terms of resource and water consumption, in terms of energy use, and in terms of waste generation. There is a finite our nature is finite, and there's an increasing scarcity of non-renewable resources. There's also an increasing stress on renewables, as we are forced to move to renewables when our non-renewable resources are running out, and this is not leaving enough space for us to develop and invest and lower the cost of renewables. There are also social risks that are associated with linear economy. There is a growing inequality, as different regions are affected differently in terms of resource availability and access to products, and the amount of generated waste. There's also climate injustice, where first world nations are consuming the most and impacting climate change the most, while more vulnerable nations are being affected more in terms of weather, extreme weather, and the rising of water levels in areas like the Asian island nations and in Africa. And finally, the economic risks associated with linear economy is that there is a rise in commodity prices, as there's also a supply shortage. And circular economy tackles all these issues. So let's look at a couple of circular business models. There are 5 basic circular business models. The first one is circular supply, where we replace traditional inputs with renewable or recovered materials. An example of this is designing a product to be handled from cradle, where the product is made, to cradle, where the product is returned or the materials are returned to be remade again or reintroduced into the production process. For example, 3D printing is being used to make tools in engineering applications. These tools, because they are 3D printed, can be broken down and remanufactured again into new tools to be reused. The second circular business model is resource recovery, where we convert waste into secondary raw materials, such as recycling and upcycling. An example of this is oil refineries. They are using their used resources to recover value by treating the byproducts of their refining process to separate oil, water, and solids. These recovered materials can be returned to the refinery to be reused as secondary materials for crude processing. The third circular business model is product life extension. We extend the life of products through repair, refurbishment, and remanufacturing. And examples of this are long life products and direct reuse. An example that we can talk about is mobile phones. In a product life extension business model, they would be made with components designed to be repaired, refurbished, and remanufactured to extend the life of the product. Instead of being swapped after a year or two, it lives on, creating much less electronic waste and being more affordable for consumers. The fourth circular business model is the sharing model. It increases product utilization by shared access, for example, co-ownership and short-term lodging. An example of this can be peer-to-peer marketplaces. Other examples can also be co-working spaces, tool libraries, and carpooling services. The final circular business model is the product service system, where the focus is on providing services rather than products, retaining ownership with the supplier, for example, leasing and result-oriented services. And here we can talk about manufacturing as a service, where businesses access manufacturing capabilities on demand without capital investments associated with infrastructure and equipment. So the key characteristics that are shared between all these circular business models is that all these business models are that there is a focus on quality over quantity, and all these models are leveraging existing materials to reduce costs. They also allow for enhanced collaboration within supply chains, decreasing the effect on supply chain stress, such as material availability and material costs. And there's also an increased customer loyalty through repeated interactions, such as the return, the refurbishing, and the remanufacturing of products. So what is the business case for circular models? There are environmental benefits, such as reduced resource extraction and waste generation. As a result, we decrease our stress on planetary boundaries and resource availability. There are economic benefits, such as cost savings from material reuse, new revenue streams from services, and access to green markets. And there is a lot of risk management involved with circular models, as they mitigate regulatory and supply chain risks by controlling the need for new commodities and addressing supply shortages in different industries. An important concept in circular economy is the life cycle assessment, known as LCA. It is a systems-based quantitative method for evaluating environmental impact of products. It is a tool used to assess the stages and impact of a product's entire life, from raw material extraction, known as the cradle, to the waste treatment, known as the grave. The LCA looks at products in terms of energy use, water use, and CO2 emissions. And the standard example of this is the ISO 14040-2006. This is part of the international standard of LCA in environmental management. So now let's look at a few real-life examples where circular economy has been applied, and so that we can understand further what it means when it is put to action. The first example we'll talk about is Levi's. The company did a life cycle assessment of their jeans, and this was the result. It starts at the cotton production, then goes to the fabric production, then garment manufacturing, then transportation and distribution, then consumer care and use. The conventional stage after this is end of life, where the jeans are thrown away. But then Levi's introduced the recycling stage, where after consumers are done using the product, they are returned and recycled, and then the materials that are recycled are reintroduced into the fabric production stage. closing the loop a little bit and decreasing the waste that comes from the end of life of the product. This model is how the linear economy works in the fashion industry, which applies to jeans as well. There's a 97% use of virgin feedstock, which includes plastic, cotton, and other materials. Per year in the fashion industry, 53 million tons are used annually for the production of clothing. Then the products are used by consumers. However, 73% of the total fabrics produced end up in a landfill or are incinerated. This is the conventional model for the fashion industry. If you look at the circular alternative, here we have the conventional production line where there's a raw material producer, there's a fiber producer, a yarn spinner, fabric manufacturer, garment producer, and then to the retailer who then sells it to the user. If we add circular economy concepts to this, the products can first be reused either by swapping, borrowing, or inheriting between users, or it can be rented or traded through retailers. The second step would be open loop recycling, where some of the fabrics are recycled to be used as secondary products such as rags, blankets, or insulation. In the fiber production stage, the waste coming from plastics can also be recycled into bottle use, plastic bottles. If you look at the closed loop recycling, which is up or down cycling, fabrics can be recycled and reintroduced into the garment production stage. Fiber can be recycled and brought back to the yarn spinning stage, and plastics can be recycled again to be reused in the fiber production stage. Using this model, we need to be a Western country would reduce 30 to 100% of its impact on several impact categories that were mentioned in the materiality of circular economy by 2050. The second real-life example is a company called John Deere Riemann. It is an engine part and component manufacturer in the US. They introduced a new model where engine components are recovered, disassembled, cleaned, and inspected for damage. All failed and critical parts are replaced with the original equipment manufacturers. But then the ones that are remanufactured, they have warranties that are equivalent to new parts, and the operating performance and expected life of the remanufactured parts is equivalent to new parts, and that's 50 to 70% of the cost of new parts. This remanufacturing process promotes recycling, resource conservation, pollution reduction, and energy conservation by reducing raw materials, reusing parts, and reducing inputs compared to the production of new parts. Here we look at the remanufacturing process. We have the first line, which is the linear process, where the core parts are managed, they are stored, disassembled, cleaned, inspected, and the ones that are qualified after inspection can go into the core recovery stage. This stage includes the machining, assembly, testing, painting, packaging, and distribution, which then gets reintroduced into the manufacturing process. And this process decreases the waste that comes from engine manufacturing and reintroduces parts that can be used again and again without compromising on quality and saving costs as well. The third and final example is Philips. They have a system called Circular Edition. They offer a portfolio of high-quality refurbished medical imaging systems at attractive prices. These systems are on average 25% lower in price compared to new Philips systems without compromising on quality and performance. They offer the same warranty, service, and training as any new Philips system, as well as reduced carbon footprint, and they claim that these are sustainable solutions that are as good as new. They basically refurbish the imaging systems that they have. This process reuses 79% of the average material weight, which reduces the need for virgin materials. Their product portfolio until now includes mobile CR systems, ultrasound, magnetic resonance, image-guided therapy, and computed tomography, therefore closing the loop on medical imaging systems and reintroducing them at lower costs, saving medical costs as well as saving waste from the manufacturing process of these products. Thank you, and I hope this has been a helpful and clear introduction to circular economy.